Okay, welcome back to Steam TV. Today I'm working with dot products. I'm going to introduce the dot product and then how to find an angle between the two vectors as well. So dot product is very straightforward. Okay, it's really just addition and multiplication. Essentially, I want to find A dotted with B. One of the most important things about dot products is that they're scalar quantities. Okay, and when we say something scalar, it's only based on the magnitude, not the magnitude in a direction. Okay, the vector quantity would be a magnitude in direction, which is like velocity. Speed is scalar. Okay, so in this case, we're really just with these two vectors. Just imagine, okay, we're giving these two vectors. This dot product is only going to leave us with a scalar quantity, which is a magnitude. Okay, if they were both velocities of like a particle in space, and they both were describing the way that this particle were moving in three-dimensional space, let's say, you may even have a third vector, depending on where this particle is moving. So basically, that's essentially what we're getting at here is that if these two vectors, let's let these two vectors equal a particle in space, they describe the movement of a particle in space, we're going to be left with a scalar quantity after taking the dot product. And the cross product we'll introduce in another video that will allow us to obtain a vector quantity, okay, which is magnitude and direction. But anyway, let's get to it. So for the dot product of A dotted with B, okay, essentially what I'm doing is I'm going to take 6, right, 6 in the I position, 12 in the Juliet, and 6 in the Kappa. And essentially what I'm doing is I'm going to basically multiply these vectors and then add them. Okay, so I'm gonna basically multiply the quantities. All right, so this is the way I like to do it. I'm gonna take 24 India, 8 Juliet, and 3 Kappa. Okay, and I'm gonna basically multiply it together, right? The positions, right? This is the I position, this is the J, this is the K, I, J, K, X, Y, Z, however you pick your poison. So basically 6 times 24, okay, is basically my new I position. 12 times 8 is my next J position. And then 6 times 3 is my K position. And then the dot product, I'm actually going to be adding these values together. So now I'm going to take 6 times 24 plus 12 times 8 plus 6 times 3 is 18. Okay. Move this down a little bit. 6 times 4 is 24. 6 times 2 is 12. 144 plus 12 times 8, 16, 8, 96 plus 18. Okay. 6 plus 4 is going to get me what? That's going to put me at the 10s, 15, 16, 17, 18, 19, 20, 21, 22. 24, 0 plus 18 is 258. Okay, that's my dot product. All right, so let's say I got my magnitude right here, my dot product, and now I want to find the angle between the vectors. Okay, essentially we have a formula for that. Okay, we do. And that formula is A dotted with B. Oops. A dot B is equal to the magnitude of A times the magnitude of B times cosine of theta. And this is one of our general formulas that we will see as we go, as we continue with dot products and cross products. Right, this is something you would typically see on your formula sheet. All right, so you guessed it. We're going to solve for theta, the angle, right? That's essentially what we're looking for. We already have A dotted with B. What did I get? 268 or something? 258? I'm going to set that equal to the magnitude of A times the magnitude of B times cosine of theta. All right. Well, I need to find the magnitude of A and magnitude of B first. Okay, so the magnitude of A is equal to the square roots, right? And what I'm doing is I'm essentially using like Pythagorean theorem, right? I'm taking all my values, I'm squaring them, and then I'm taking the root of it. That's exactly what I'm doing. So I'm going to take 612 and 612 and 6, right? 36 times 2 is what, 72, and then plus 144. That's going to give me, I just lost the numbers. 144, sorry, 216. Can't always do the simple operations, but it's okay. So the square root of 216 is 14.7. I mean, you could leave it as this if you don't want to have like a nasty decimal on your paper. You could leave it as square roots of 16. Obviously, regardless, we're rounding here. All right, now the magnitude of B, whoops, at daisies. Same scenario. Gonna take 24, 8, and 3 plus 8 squared. Okay, I'm gonna save myself the brain power. 64 plus 9. 649, the square roots of 649 is 25.5. All right. So now I'm going to take, basically I want to solve for cosine of theta. Cosine of theta is 24.5 plus 14.7. All right, so that's 40.2. All right. 258 over 40.2. Gets me 6.42. Theta is equal to, right, the inverse cosine of that answer. Make sure your calculator is in degrees, okay? Oops. I think I'm in the right thing. Just a second. Okay, so my apologies. I'm going to admit I made a mistake here. I meant to multiply, not add. So this number is actually 365. I was just to multiply my magnitudes together to 25.5 and 14.7. Okay, so now I get 258 over that 375, which is 0.69. Okay, which is more like it. Now I'm in range, and now I'm going to get 46 degrees, approximately 46.5 degrees. Okay, so essentially that's how you do dot products, all right? Very straightforward, to the point, and I hope this makes sense. Obviously, sorry about that mistake. Again, we're obviously multiplying the magnitudes A and B. So if you were paying attention, maybe you caught my mistake. If not, well, hopefully you watched to the end to see that I made a mistake. But I'm not going to edit it because I feel like it's important to leave that kind of thing in there. We're not perfect, and don't get discouraged with math. I was not very great at math myself coming into things, and now I'm an engineer. I really had to work towards it, and I really enjoy it now. I enjoy mathematics and like this kind of stuff. Just, the visualization. I got two vectors, and this is approximately 46.5 degrees. So I enjoy the visualization, but in fact, these vectors are probably more like, offset of one another like that, anyway. So that's essentially how you do that product. And if there's any questions, please, again, I'm new with this, so please bear with me. I'm doing my best, but I'm doing my best to obviously go through things. But yes, please like, comment, subscribe. Let's build this up because it would be nice to someday be able to donate any kind of uh, you know monetary amount that I make through YouTube. I would like to actually donate towards scholarship eventually, so that'd be nice. That's what I'm trying to build Steam TV. So anyway, I appreciate your support. Like, comment, subscribe. Stay tuned for more. 10 minutes were pretty good on that one.